Yesterday, we were discussing cumulative frequency curves. When we started it, I said that we will be discussing quartiles, percentiles, range, quartile range. We discussed the interquartile range, the quartiles, but we did not discuss percentiles. So today we'll start with discussing percentiles. ठीक है? अच्छा जी, परसेंटाइल्स डिस्कस करने से पहले ये मैंने बुक का नाम यहाँ पे लिख दिया हुआ है। बुक जिनकी है वो है मोहम्मद जवाद सईद, टॉपिकल S1 है, ये स्टूडेंट रिसोर्स से आपको ये मिल जाएगा S1 का। तो आप इसको जितनी जल्दी मंगवा सकते हैं मंगवा लें, ताकि आप इस वीकेंड के ऊपर आप इसके ऊपर काम कर सकें, ठीक है? क्योंकि इंशाल्लाह द फर्स्ट टॉपिक विल बी कंप्लीटेड today or tomorrow, means within 1 or 2 days. Okay, now let's start with percentiles. Percentiles are the points which divide our data into 100 equal parts. Just तरह से quartiles, we said that quartiles divide our data into 4 equal parts. In the same way, percentiles divide our data into 100 equal parts. ठीक है? तो अगर हमने फर्स्ट क्वार्टाइल फाइंड करना होता था तो हम क्या कहते थे? इट इज 1/4 ऑफ आवर डाटा. सेकंड क्वार्टाइल फाइंड करना होता था, आई विल जस्ट राइट इट डाउन सो दैट व्हाट आई एम सेइंग आप लोगों को क्लियर भी होता जाए. फर्स्ट क्वार्टाइल जब हमें चाहिए होता था तो वी वर सेइंग इट इज 1/4, ठीक है, 1/4 ऑफ n, ठीक है. और फॉर सेकंड क्वार्टाइल इट वाज 2/4. ऑफ कोर्स 2/4 मींस 1/2, means half of our data. And second quartile, we know very well it is the median. Okay. Or third quartile, it was the 3/4 of our data, 3/4 of summer. ठीक है? तो इसी तरह से हमारे पास जो percentiles हैं, they are dividing our data into 100 equal parts. So whichever percentile you want to find, the total portions which we have are 100. If you want to find the 5th percentile, that means 5/100. The position for, let's suppose we want to find the P17. We want to find the position for 17th percentile. Okay, first we always find the position. Now for the position, what we are going to do, we are going to divide 17, because we want to find the 17th percentile over, and percentile divides the data into 100 equal parts. So 17/100 into n. N means the total number of values, the total frequencies which we have. Okay? So in same way, in general, we can write, if you want to find the nth percentile. Now this is, no, I won't use n because we have already used it. We can say m. If you want to find the nth percentile, what would this be equal to? m, जो भी percentile आपने find करना है, over 100 into n. N means total number of values. Okay? So you can easily find out the percentiles as well. Okay. Now today's main topic is, we are going to start box and whisker plots. Box and whisker plots we haven't discussed in O-levels before. We will study it here. One more thing was, cumulative frequency curve, we did not discuss its uses and its merits and its demerits. Okay? So before starting box and whisker diagram, we will just see the uses, the advantages and disadvantages of cumulative frequency curve in a very quick way, inshallah. Okay, ji. Let me add. These are the uses of histogram. Okay, let's discuss the uses of histogram first, and then we can move on to the cumulative frequency curve. Okay, in histogram, we did not discuss the uses of histogram. So in histogram, you can easily tell the shape of our distribution. ठीक है, आप जरा देखें यहाँ पे histogram, we have drawn a histogram over here, the histogram. Okay, आप अगर इसके ऊपर आप draw करें, excuse, चलें जी. Okay, so we have a histogram here. Let's see if we draw a smooth curve over here. Let's see कि वो क्या shape बन रही है उसकी. I'm just going to draw a rough sketch over here, a rough curve. It's like this. It's getting a peak, and then the data is like this. There's a tail towards the right side. Most of the data sets are on the left side, and the tail of the data is towards the right side. तो जब भी आप histogram draw करते हैं, तो you can easily tell what is the shape of your distribution. You can tell easily whether it's symmetrical, approximate-symmetrical, or it's skewed. ठीक है? So this distribution is skewed. And what type of skewness is here? It's positively skewed. Positively skewed. क्योंकि the tail is towards the right side. Positively skewed. Let's move to the next one. This one. If we draw a smooth curve here, look, the tail is towards the left side. Okay? It's towards the left side. So this distribution, whenever you draw the histogram, you can easily tell the shape of the distribution. It is negatively skewed. So this is one of the uses of histogram, that we can easily tell the shape of the distribution. This distribution is negatively skewed. We can easily tell out the outliers. If most of the values are on one side, and one or some of the values are very far away from the main cluster, so we can say that that is an outlier. But this thing is not asked in our course to find the outliers in a histogram. It's mostly we just have to tell what is the shape of the distribution. It can be positively skewed, it can be negatively skewed, or you can tell that how many mods the distribution have. Look at this distribution. We have discussed earlier that a distribution can have one mod or it can have more mods. In this distribution, how many mods do you find? Okay, let's see if I draw a shape here. Look, now this distribution is having two peaks. It's reaching two peaks. Okay? And therefore, this distribution is not a unimodal distribution, it is a multi-modal distribution. And luckily, it's not just multi-modal, it's bimodal distribution. So in a histogram, when you draw a histogram, you can also tell that how many mods the distribution has. Okay, now this is the disadvantage of a histogram. Disadvantage. What is the disadvantage looking at this picture? Disadvantage. Look, in a histogram, these are the histograms of 4 different, you can say, maybe these are the marks of students, okay, in different subjects, in subject A, subject B, subject C, subject D. Okay? Comparison of different distributions becomes quite difficult in a histogram. This is one of the main disadvantages of a histogram. Okay? Comparing two different distributions or two different aspects in a distribution becomes quite difficult if the histograms are plotted in different. Look, the first, for A, we have plotted the distribution here. For B, we plotted it here. For C, we plotted it here. For D, we plotted it here. Okay? If you want to compare the distribution A and distribution D, just looking at it, it's means we can just tell an answer, but we cannot be 100% sure. ठीक है? Maybe a glimpse में it's looking as though they're exactly the same. ठीक है? But they're not exactly the same. They're different. So one of the biggest demerits of histogram or the disadvantages is that it's difficult to compare, to make comparison using a histogram. Okay? And one more thing, individuality. The individuality of data is finished. Individuality. Hello? Hello?